Stroke is among the top leading causes of mortality in Malaysia and around the world. The incidence and prevalence of ischemic stroke increased nearly triple in the 5-year period, from 34.2 to 96.2 per 100,000 people, while those of hemorrhagic stroke increased at a lower rate from 10.6 to 21.1 per 100,000 people. Malaysian Burden of Disease and Injury Study, stroke is at the third place among the leading causes of total burden, contributing 7.9% of total disability-adjusted life years. People who suffer from stroke will result in hemiparesis or one-sided body weakness. This results in poor hand function, reduce the independency level in performing activities of daily living. Upper limb weakness and dysfunction is one of the most difficult impairment to restore post-stroke compared to lower limb. Neuroplasticity is the ability of the brain to form neural networks by reorganization through axonal sprouting and forming new synaptic connections. However, this brain plasticity needs to be guided and directed to achieve intended recovery and function and to prevent maladaptive behavior. Rehabilitation intervention plays the crucial role in restoring and promote neurorecovery. Neuroplasticity is the fundamental concept underpinning every post-stroke rehabilitation restoration intervention. Rehabilitation intervention have to fulfill four main principles: 1. Repetitive, 2. Intensity, 3. Task-specific, and 4. Biofeedback. Mirror therapy is one of the rehabilitation interventions used to promote and assist neuron recovery of the upper limb in the stroke rehabilitation. It gives visual feedback by placing a mirror between the arms to trick the brain. By the image of a moving non-affected limb gives the illusion of normal movement in the affected limb. By this setup, different brain regions for movement, sensation, and pain are stimulated. To enhance the biofeedback, sometimes the therapy will move the affected limbs in the box to create a motor proprioception sensation feedback. However, sometimes the principle of rehabilitation is difficult to fulfill. Intensity, task-specific, repetitive, and biofeedback. The problems are: 1. Intensity and repetition are very much dependent to the therapist. Due to the small space in the box, complex movement is difficult to imitate and intensity cannot be provided. 2. The motor imitation provided by the therapist poorly imitate normal or natural movement of the hand. 3. Task-specific training impossible to be provided due to lack of natural hand movement. Introducing MyERAT. MyERAT, known as Malaysia Exoskeletal Robot Assisted Therapy, is an exoskeletal robotic orthosis used to provide hand movement to the hemiparetic limb by imitating the movement of non-affected limb. This mechanism will provide more intensity, repetition, and provide proprioceptive motor feedback by imitating natural movement of the hand. MyERAT consists of two parts, controller and exoskeleton. The principle behind the innovation of MyERAT is combining the concept mirror therapy into exoskeleton. Mirror therapy will provide visual that produce sensory feedback, while exoskeleton will provide motor that produce proprioceptive input. The exoskeleton at one hand will imitate the movement of controller at the other hand, such as finger movement and wrist movement. Next is the mechanism used for MyERAT. The power used is battery, each hand powered by 7.4 volt 1100 mAh rechargeable battery. Programming used is Arduino IDE. Exoskeleton is designed using CATIA software. The material used is polylactic acid filament. MyERAT controller will be worn on non-affected limb, while the MyERAT exoskeleton on affected limb. The patient will undergo extension and flexion exercise for the affected limb based on the non-affected limb movement via radio frequency wave. How MyERAT can solve the problems? 1. Imitate the hand motion naturally by giving motor proprioceptive feedback. 2. Can provide task-specific training. 3. Can enhance the therapy by giving intensity and repetition in a limited space in the box. Commercialization. 1. Low cost due to local innovation. 2. Potential IP. 3. Large market potential due to increased stroke sufferers that require rehabilitation intervention. Novelty of this product. 1. One of the local innovation that imitate the movement of the hand from the unaffected limb. 2. Innovation that underpinning the concept of neuroplasticity and principle of rehabilitation medicine. 3. Homegrown Malaysian-made innovation, integrating IR 4.0 in medicine intervention. 4. Universal, can be adapted and adopted to other rehabilitation intervention, functional hand training, chronic pain treatment. Thank you for watching and please support MyERAT.